Welcome to Station 4, where we are reading graphs, reading and creating and analyzing graphs of systems of inequalities. I know that it's an inequality because we do not have equal signs in our equations, right? And we see some dotted lines in our graphs, and we see the shading. So those are all signs that these are systems of inequalities, not systems of equations. Remember that a system of equation has one solution. One solution, well, it has one, none, or infinite, right? But that one solution is always the point, I'm going to call it A, comma, B, whatever, X, comma, Y, where our two lines cross and meet. However, when it's inequalities, it's the space in between our two lines that match the rules of the greater than or less than, right? So let's solve this. Our first one says solve the systems of inequalities by graphing. Y is less than negative x plus 3, and y is greater than x minus 1. So the first thing I think we should do is start by eliminating maybe a possible answer choice. And the first one that I see we can eliminate is answer choice A. And A cannot possibly be a solution because of this solid line right there. Right? Solid lines let us know that one of these two equations should have had the equal to underneath it, right? But this is a less than, this is a greater than, neither one of them say equal to, so we should have only dotted lines. The next thing I want to see if we can eliminate, let's eliminate maybe one or two more before we even start looking at the shading. Let's look at our y-intercepts. Our y-intercepts, right? This first one, plus 3, tells us that one of our lines needs to be at plus 3. Wait, let me zoom way in. I'm sorry here. There we go. That's better. So plus 3 means that 1, 2, 3, we should have a point that lies right here on every single graph, right? And minus 1 says we should have a point that lies right there on every single graph. Now A we already knew was wrong because of the solid line. A is also incorrect because these y-intercepts are not being properly represented. So let's see, B, 1, 2, 3, and negative 1, B is good. C, 1, 2, 3 looks like it's there. Negative 1 is right there. Negative 1's right there. Our dotted line is not laying on that. C cannot be a solution. Okay, C is definitely not it. And D, let's look. Oh, this is a, right, negative 3 is, or sorry, positive 3 is here, negative 1 is here. Neither one of these two lines lay on that. B should be our solution, but let me just make sure, because 3 and 1. So we start at 3, and our slope is negative x, right? So down 1, there, our slope is negative 1. And then less than means we're shading underneath the top line, right? Okay, so that line looks good. Y is greater than x minus 1. Here's your minus 1 plus 1. So this one has a positive 1 slope. This one shades below, oops. Nope, above, it's greater than, above our line. Yeah, B is definitely it, right? If I compare where I colored on both of them, B is the solution here for number 1. All right, let's move here to number 3. Which point is a solution? So looking at the graph, these are our solutions here in like the yellowy color, right? The first line is shaded in the red above. This line here is shaded in the green below, and then they come together in this yellow. So only a point that lies inside of this section right here is going to be a solution on this particular graph. So A is negative 3, 4. Well, 1, 2, 3, 1, 2, 3, 4. Ooh, interesting. A could be it. 1, 2, 3. A could be it. Let's come back because it is lying on both lines. Let's come back to A in a minute. Let's just make sure B, C, and D are not them. So then let's do negative 4, 3. 1, 2, 3, 4, 1, 2, 3. That's definitely not it, right? That lies in the green section. So B is not a solution. C, which is 0, 6, 0, 1, 2, 3, 4, 5. 1, 2, 2, 3, 4, 5, 6 lies there. All right, maybe C. D is over 1, up 0. Oh, I think A, C, and D are all solutions to this system of equation. Okay? Can you name maybe one more solution that is definite? Anything in here is definitely a solution to this system of equation. And then there's 11, which is not. Which one is not a solution? Okay? So we're going to do something similar. Here our solutions are in the gray. These are our solutions. I notice that our red line is definitely dotted here. I'm not sure if in this last one, the picture's a little small maybe. That could be a dotted line. I'm not positive. If this is a dotted line here, then our only solution is this guy. But because it's kind of difficult to see, we'll say they can all be solutions. Anyways, back to 11. Which one is not a solution? So 0, -1, over 0, down. Oh, that lies on the dotted line. We'll come back to that. 6, -2. Right? If it lies on the dotted line, it is not a solution. I'm thinking A is going to be our answer. Again, this is a really small graph. Sorry about that. It's a little hard to read, so we're doing the best we can. But 6, -2. There's 4. There's 6. -2 is definitely in the gray. That is a solution. The question is asking us which one is not a solution, so C cannot be the correct answer. B is at 4, 0. That's definitely in the gray. That's not a solution. D is at 0, 3. That lies on the blue line. This blue line here is definitely solid, which means this is a solution. Right? Which means A is definitely our answer here because we don't want solutions. We want non-solutions because it's on the dotted line. So that's the reason why A is the correct answer to number 11, because the point 0, -1 lies on the dotted line, and dotted lines mean that it is not a solution.